Hi guys, my name is Isaac Stanek, and today I'm going to walk you through my project, the Sunnyside breakfast app. So the idea behind this project is pretty simple. It's an online ordering platform for a breakfast food truck. You can think of it like a smaller, more focused version of apps like DoorDash or Uber Eats, but just specifically for one business. So with this app, customers can go to the website, browse the menu, search for items, add food to a cart, and then go through a whole checkout process all directly in the browser. So from a technical side, this is a full stack application. The front end is built using Angular and TypeScript, with Bootstrap handling some of the design and the layout. I also used RxJS to manage real-time data updates across the app, and on the back end, I used PHP with a MySQL database to store and serve the menu data through an API. So all of these technologies work together to create a dynamic and responsive user experience instead of just a static website. So now I'll go ahead and I'll walk through what the app looks like and how it works. So on the home page, this is the landing screen that users see when the application loads up. It gives a quick introduction um, to the brand, and it has a clear button that takes the user straight to the menu. The goal here was to keep things simple and not overwhelm the user, just to get them to the food as quickly as possible. A couple other things I added were just some customer favorites and where we're located. So when we click on this Order Now button, it pulls up the menu page, which is the core of the app. So when this page loads, it sends a request to the backend API, which retrieves all the food items and then displays them as cards. And each card shows the item's name, price, the cook time, and an image. So on the side, or the top, there are category tags like breakfast, drink, and sides. So when I click one of these, the menu filters instantly to show only the items in that category. So if I click on sides, it shows just my sides. If I click on drinks, it shows all three of my drinks. And if I click on breakfast items, it shows everything else. So notice that the page doesn't reload. Um, that's because Angular updates everything dynamically. So that's one of the main advantages of using a framework like this. Also, the search bar. At the top, if I type something like egg, the app performs a fuzzy search, and that just means it doesn't require an exact match. It just looks for those letters that I typed in order within the item names. So this makes the search feel more flexible and user-friendly compared to a strict filter. So if I click on a specific item, like French toast, it brings me to a food details page. So this page just shows more information about the item, which includes a full description, price, and here's the cooking time that I talked about earlier. And there is also a little heart icon that allows the user to favorite items right here. And these favorites are saved in the browser so they stay even if the user refreshes the page or comes back later. So if we favorite it in here and we come back to the menu, boom, it's favorited. So now let's add something to the cart. I'll add a couple items. We'll do chocolate biscuits and gravy, waffles, and we'll do an orange juice. So now, as I do this, you can see the cart icon updates in the header in real time, and this is powered by our RxJS, which keeps different parts of the app in sync automatically. So now when I click on this cart and I open the cart page, you'll see all the items I have in here. So in this page, I can increase or decrease the quantity or remove these items entirely, and the total price updates immediately. So if I want to remove this French toast, my total price here and my cart both update automatically. So we go from 5 to 3 and $40 to $20. And it also updates here in the header as well. So everything here is dynamic, so there's no need to reload the page or manually refresh or do anything. So now, when I'm ready to check out, I click this checkout button, and a panel slides from the right showing an order summary and a payment form. So when I click here, it shows me my payment form. So the form collects a card number, an expiration date, and a CVV. It also validates the input in real time. So for example, if the card number is too short or formatted incorrectly, it will show an error. So for this I type it too short, you notice the bar is red. But when I go all the way, it turns green. So once everything is filled out correctly, I can place an order. So let's fill this in with some mock data. Okay. And now I can place the order, submit payment. So after submitting, the app clears the cart, which you'll see in a second. But first it tells the user that their order is confirmed, and it takes me to a thank you page. And as you see, the cart here is emptied. So in a real world version of this is where a receipt or a confirmation email would be sent to the user. So we'll click on back to home, take us back to our home page. So some technical highlights, some technical decisions behind this project were first just using Angular and its component-based design. So this entire app is built using standalone components. So each part of the UI, like the header, the search bar, the menu items, and the pages, it's its own reusable component. So this keeps the project organized and makes it easier to manage as it grows. So second, our services and our reactive data. So all the main logic is handled in services like the cart service and our food service. So these services use our RxJS to create data streams. So when something changes, like adding an item to the cart, every part of the app that depends on that data updates automatically. And then third, our local storage. Since there's no full user account system yet, I use the browser's local storage to save the cart, favorites, and user info. So I'll give you a quick example of that. So if we go here to a login page, I can type in a random name, email, and password. Same email.com, and we'll type in a password 1234. It's just mock data. This is just what it would look and feel like if we were using a real thing. And yeah, so here it takes you to this profile page, which just displays your info, a hard-coded favorite foods, and a hard-coded order history. And so here we can log out, and we go back here. There's also a guest option, which just shows nothing. So yeah, so now some backend integration, which is the core of this project. So the backend is built using PHP with a MySQL database hosted on a remote server. So its main job is just to handle requests from the front end, which is what you see here, and return the data. So when the Angular app loads the menu, as you can see, it sends a request to the backend. The backend connects to the database. It retrieves all the food items from the food table and sends them back as a JSON response. So that JSON response is what the front end uses to display everything on the screen. As you see here, when the menu is loaded, it pulls all this data from the backend. So the database stores all the details for each item, including the name, the description, the price, the cook time, the image, the tags. The tags are especially important because they allow the front end to filter the items by the category. So this setup makes the backend the single source of truth. Instead of hard coding all that data into the front end, everything comes from one central place in the back end. So that's a big improvement compared to some other small projects. If something needs to change, like updating a price or adding a new item, it only has to be updated in the database. And every user will automatically see the updated data once I update it. So it also makes the app more scalable and much closer to how a real-world full-stack applications are built. So let's talk about the API and its performance. So the API is hosted separately, serves all the menu data. To improve performance, I used caching with RxJS, so the app doesn't repeatedly make the same requests when the user navigates between pages. And then finally, a responsive design. My app is fully responsive, so on larger screens, the checkout appears as a sidebar, and on smaller screens, it switches to a full page layout. So I'll add an item here. We'll go the checkout, and if we want to see this on mobile, we'll click checkout, And as you can see, it slides all the way across instead of just a third of the way. And also on mobile, it looks really good and nice and clean, as you can see. And so this is handled using Angular's breakpoint observer, which just detects the screen size and adjusts the layout accordingly. So some challenges that I faced during this project. One of the biggest ones was keeping the cart synchronized across all the components. At first, I tried passing data manually, but it quickly became messy, and so I switched to a behavior subject in our cart service, and that solved the problem and made everything update automatically. So another challenge was the checkout animation. Getting the panel to slide in smoothly without affecting the layout took some trial and error with the CSS and positioning, but I finally got that figured out. Overall, these challenges helped me better understand how to structure larger applications. And in conclusion, to wrap up everything, this app is a full stack web application built using Angular, TypeScript, Bootstrap, PHP, and MySQL. So it provides a complete ordering experience from browsing the menu to placing an order while using a real backend API to deliver data. If I continued to work on this project, the next steps would be to add a real user authentication system, integrate a payment processor like Stripe instead of just my manual form, and building an admin dashboard so the business owner can manage the menu and all the orders. But this project was one of the most challenging ones I've worked on, but also one of the most rewarding because it reflects how real-world applications are actually built. So with that being said, thank you.